ES6 introduced promises, which are a different way of working with asynchronous functions. To understand the same, let's take an example. I'm going to create a new file here called ex13.js, and let's write a function here that takes two numbers as parameters and divides one by another and supposed to return the result. So this is how it's going to look like. Let's call it as function divide. It takes number 1 and number 2 as parameters, and all I'm supposed to do is to check if they are numbers, and if they are not, throw an error. So I'm going to check here if type of n1 not equals to number. I can say here throw and then a message saying that first argument is not a number. Similarly, I'll check here if type of n2 not equals to a number. Then again, I'm going to throw an error saying that second argument is not a number. And in case if they are numbers but second number is equals to 0, I want to tell that cannot divide by 0. So I'll say here if n2 triple equals to 0, then I'm going to say here throw cannot divide by 0. And if everything is okay, I want to now return the result of n1 divided by n2. I'll say return n1 slash n2. Now that this function exists, let's make use of this. But before calling, I just want to print a message here, something like start of script, and then I'll type here let a equals to 12, b equals to 5, and then I want to calculate the result of 12 divided by 5. I'm going to say here let c equals to divide a and b as the parameters, and then I'll print the result by typing console log result of division is, and then I'll just type c. At the end, I'll also say here console log end of script. Now the reason I'm printing start of script or end of script is to show you that all these lines of code get executed one by one in a synchronous style, and then I want to convert this function into an asynchronous function using promises. To execute this file, let's go to a command prompt and get into the directory. And then I want to type here the command node followed by ex13 or ex13.js. And since we get 12 and 5, there is no problem. So we see that start of script, result of division is 2.4, end of script. If I go back to the code and then change this to a text, for example, instead of 12, I'll type ASD, go back to the command prompt and then run this. You will see now we do not get the end of script. We got the start of script. The execution of this divide function threw an error, and that error caused the application to break, and I did not see the end of script. And of course, I got an error saying that first argument is not a number. Now this is the same thing with all other conditions, and let's not worry about that. So let me put this back as 12, save this. Suppose if you want to convert this into an asynchronous function, then when you call this asynchronous function, there will not be any return value because the execution happens in a deferred way. So we have to supply a callback as what to do with the result. To do this, let's convert this into an asynchronous function. The first thing that you have to do is to write a third parameter, which is supposed to be a callback function, and let's name this appropriately as callback. And the only thing that you're going to do is if callback is not supplied as a function, we have to throw an error. So I'm going to type here if type of callback is not equals to a function, then we're going to throw an error. Callback must be supplied and must be a function. And I'm going to introduce an asynchronous block over here by calling the setTimeout function, which takes a callback as a parameter and then a duration. Since I don't want any delays, I'm going to put a 0, and all this code is going to go inside this with a small change. So I'm going to cut this first and then paste it inside over here. The next thing we want to do is to see if there is an error, and whenever there is an error, we're going to call the callback using this as my first argument. So remember, Node.js follows the error first approach for the callbacks. So instead of throwing an exception, I'm going to cut this and I'm going to call the callback by supplying this and no second argument. I'm going to say return here because we want to go back. Similarly, I want to remove this and then type here callback and then pass this argument as the only argument, which is an error. Similarly, the same thing I'm going to do it for this. I cut this, call here by saying callback and this error message and return. And finally, if there is no error, we do not want to return because we want to supply it as an asynchronous callback result. So I'm going to cut this and then say here callback, and since there is no error, we're going to say null as the first parameter and the result of division as the second parameter. Now the function has been converted into an asynchronous function. When we call this divide function, there is no more return values here, so I'm going to get rid of this. But we have a third parameter here called callback, which is supposed to be a function. I'm going to write a callback handler here, which takes error and result as two parameters. We're going to check here if there is an error. We're going to say console log there was an error, and we'll say error. Else we'll say here that console log the result of division is, and then we'll say result. This console log is no longer required. I'm going to remove that, save this. Now to execute the same, we'll go back to the command prompt and run this. But just remember, we have now 12 and 5 which are valid parameters, but because divide is now an asynchronous function, so the console log for start of script comes first. This just transfers the control and comes back instantly, and later point in time the result of this division comes up and we see one of these. So we're going to go back to the command prompt and run the same, and you will see that start of script, end of script comes without any problem. The result of division is 2.4, and let's go and change this to some ASD. Save this, go back to the command prompt, rerun the same thing, and once again you will see start of script and end of script comes without a problem. There was an error, first argument is not a number. The only reason why you may get an exception is when you don't supply this callback at all, and in which case we're going to actually receive an exception and the execution of the application may break. So this is how traditionally the JavaScript supports asynchronous. We have to depend on some other asynchronous functions. But in ES6, they introduced the concept of promises. So let us convert this function into a promise-based asynchronous function. So in case of a promise-based operations, the return value of this function when we call is a promise object. So there is no callback here. So we're going to remove this callback and then write a return statement which returns a new promise which is going to have some callbacks. And obviously, because we are returning a new promise object, we can now assign this over here to a result. So I can call this here as let result equals to. So we are going to get the promise object over here. The promise constructor takes a callback as an argument, and the callback receives resolve and reject, which are two functions that we have to call. And inside the body, we're going to do all our logic. And since there is no callback, we don't have this particular code, so I can get rid of this. Now, if type of n1 is not a number, we have to report this as an error. I'm going to cut this and paste over here. We don't have anything called callback, but that is where this reject function comes into picture. We're just going to say reject. The first argument is not a number. That means you get a promise and the promise has been rejected. We don't need to call the return because the reject will take the control away anyways. The same thing applies to these two as well. So I'm going to cut this from here, paste it over here, and then instead of callback, I'm going to call it as reject. And I don't need these two return statements, so I will get rid of them too. The last part here is where we called the callback with null and n1 divided by n2. We don't have to do that because now the promise is going to be resolved because there's no errors, and I simply have to say resolve n1 by n2, and then I don't need this set timeout at all. Now this is how you have to write a function that returns a promise. So which means as soon as you call this here, the control comes over to here and returns a promise object. So result is a promise object. And then we're going to continue with our stack here, which prints this console log end of script. And later the actual logic of this function gets processed. Now when you get a promise, the promise has only two outcomes. Either it is resolved or it is rejected. If it is resolved, then you can access the resolved result in the then function. In case of an error, you call the catch function to get the error messages. For example, I can say here result.then. We now get the result as callbacks parameter. I can say here console log result of division, and then I type here result, and I can also type here result.catch. In case of an error, I can type console log there was an error, and the error message is error. So save this, and now we have a neater mechanism where I did not have to depend on set timeout for asynchronous functions. I did not have to supply callbacks. So I just have to call this as a regular function. We get a result, but this time it's not actually the result, it's a promise object, and then we are using a then to get the result and catch to get the error. And it is still asynchronous, which means that we get the start of script first, end of script second, and then one of these two statements. Let's change the first parameter to 12, save this, go back to the command prompt, try out the same thing. So I will run node ex13.js, and you'll see that we got it in an asynchronous style, which means we got the start of script, end of script, and the result comes later point in time. Similarly, if I had something like asdf, save this, go back to the command prompt, you'll still see that there was an error, but we got the start of script, end of script. There was an error, first argument is not a number, and then of course it's giving the details of what actually went wrong over here. Now the general convention to write this would be to say divide a by b, and then you say dot then you say here dot catch. So this is the general way of writing. So you make a statement chain here instead of assigning that to a variable. So it's like do this job, and then when it is resolved you do this, when there is an error do this. So save this, go back to the command prompt, run the same. Since we are passing asdf as the parameter, we get the error. And then we go and supply a proper number. Let's type here 11. And then when I run this, and you can see we get the output in a much neater way. Now, ES7 introduced two keywords called async and await, which makes this particular call, the promise-based asynchronous function calls, much simpler to read. So we don't have to write this dot then or dot catch callbacks. So to modify this, I have to first collect the return value of the divide, which earlier was a promise. Now I can say here let result equals to await, and then say divide. So what actually we are telling here is that hey, wait for the result of this to be resolved and then give me the result. So this time result is no longer a promise but the actual resolved value, which is the result of division. So what happens if the promise was rejected? Then the actual rejected result, such as these strings, will be thrown as error messages from here. So we may have to put this in a try catch. So now that we have the result, I can directly display that result over here like this. And then we're going to say here, let's select this and then put a try catch. And inside the try block, I'm going to put this. If there is an error, that's the rejected value from the promise. And then we're going to say here console.log, there was an error, and probably we can change the name to error. We don't need this then and catch anymore. So this is how it's going to look like. Even though this code looks like synchronous, which means we feel that it is all executed one after the other, but it is not. Under the hood, it is still an asynchronous function, which means that we get this start of script, we get this end of script, then only one of these two will come. The only requirement of this await keyword is that this block or the statements which include the await keyword must be included in a function marked as async. Since we don't have any function over here, either we may have to write a function which is async, or right now for the time being I can put it in a set timeout and then type an async function and then probably 0, and here I can put this function and that's not a problem. Let's save this, go back to the command prompt, try running this, and then we still get the similar result in case of an error like some ASD here, and then go back and try, and we still get the result just like the previous examples, except that this block is now much more simpler than by calling promise.then.catch.